Once a SIL has been determined, that SIL is used to guide the level of engineering rigor applied in designing the system. An example can be found in the engineering technique tables of IEC 61508. Techniques that must be used for a SIL are said to be highly recommended, which means they must be used unless there is a truly compelling argument that they are simply not applicable. Other techniques are said to be recommended. That means they're a good idea and should be done to the degree practical, but are not strictly required for 100% of the project, as long as the result is still of acceptable quality. Additionally, some techniques are said to be not recommended, which means that they are prohibited when building systems. As mentioned on the previous slide, for this safety standard, SIL 1 is the lowest integrity level and presents low risk. Generally speaking, SIL 1 systems require a reasonable level of engineering rigor, but not a lot of special techniques for safety. On the other hand, at SIL 4, a significant number of specialized techniques are required to not only achieve safety in practice, but also so that everyone can know that the safety has actually been built into the system. This example table is extracted from one of many pages of such tables in the safety standard. You can see that for SIL 1, a number of techniques are recommended. Only one technique is highly recommended, which is using structured methods for writing the code. At SIL 2, there may be significant injuries, but no one is expected to die from this type of failure, so more techniques are recommended, but there are no additional highly recommended techniques. It is interesting to see that the use of artificial intelligence for fault correction and dynamic reconfiguration are forbidden starting at SIL 2. That's mostly because the system that is tested with these techniques is not going to match what the system in the field actually does due to the reconfiguration. At SIL 3, people can die due to a system failure, and a significant number of additional techniques become highly recommended at that SIL. At SIL 4, the consequences can be even worse, and many more techniques become highly recommended, which again means that you basically have to do them. It is common in safety standards to see this type of significant difference when the line is crossed between a SIL 2 injury type category and a SIL 3 fatality type category. The idea behind this graphic is that as SIL increases, more engineering rigor is applied, and not just applied in general, but applied according to a preset list of defined activities that are contained in the appropriate safety standard for your domain. Thus, determining a SIL for a particular hazard directly determines what construction techniques, analysis techniques, hardware redundancy structures, and other approaches must be used to ensure an adequate level of safety.